Crowdsourced geographic information is user-generated content contributed by a large number of volunteers. The collected geo-datasets are a free alternative to commercial datasets and governmental agency data. This presentation reviews common methods for collecting and accessing crowdsourced geographic information from data portals. It also explains some of the license types and restrictions that come with the use of crowdsourced geographic information. Crowdsourced data is collected via several methods. Smartphones, tablets, and GPS-enabled smartwatches are all examples of mobile devices that, when combined with mobile apps, provide a common method to collect and share spatial data. These apps span a variety of purposes including social media, sport tracking, photo sharing, business, mapping, and ecology. For mobile devices, the user's current position is automatically geocoded. For example, coordinates are associated with the photograph when taking a picture of a plant in the field. Web portals provide users with the opportunity to contribute individual observations without a mobile device. For example, web portals enable adding a point of interest to Google Maps or uploading a photograph. Web portals are useful to translate field observations that are recorded with paper and pencil into digital information. When faced with many historic field records or after an extensive field trip, bulk upload procedures are a convenient method to contribute high-volume data sets to a crowdsourcing portal. Data editors allow updating, digitizing, and editing feature data on mapping platforms. Data editors come as mobile apps, as browser plugins, as standalone applications, or as extensions to existing GIS applications. They are commonly used to edit features such as roads, buildings, land use categories, or GPS tracks from sport apps. Data access methods vary between the different crowdsourcing data portals. The easiest access is provided when data can be directly downloaded from the application website without the need to use programming code or installation of download libraries. This method is quick and easy to handle, but typically limits the data volume that can be downloaded at once. One platform which offers direct data download is iNaturalist. iNaturalist is a citizen science project which collects observations of organisms across the world in the form of photographs, sound recordings, or visual sightings. In the following example, we downloaded all records of the arboreal termite Nastotermes corniger from iNaturalist. The map interface shows the geographic location of available records after typing the species name into the search field. iNaturalist offers an advanced online data download form which provides multiple filter settings. In this case, we opt to download only records for observations that come with a photo. Based on the query settings, a data preview is generated, which in this case identifies 13 records. Next, the user can choose data columns to be exported. We keep the default setting and include all columns for the data export. Upon clicking the export button, the dataset is generated and can then be downloaded as a CSV file. It includes columns that relate to time, location, observation methods, and description of organism taxa. Other columns provide URLs to observations and their related photos. Another common method for data access is the use of an Application Programming Interface, or API for short. An API is a well-defined request-response system where servers respond to client application requests that are submitted in various programming languages, such as Python, PHP, Java, or Perl. APIs are used on websites with considerable data volume and demand. API documentation for each platform defines the list of accepted parameters for different functionalities, along with the expected output. An example of an API function is to search for tweets within a given radius from a point location. This returns a response in JSON format. Part of the code that implements such a Twitter search function in Python is shown in this figure. VGI and social media platforms that provide access to at least some of their data through an API include OpenStreetMap, Flickr, Yelp, Mapillary, Twitter, Foursquare, and Facebook. Many commercial applications use proprietary base data. This is then supplemented through crowdsourcing. These applications allow access to only part of their data, mostly those with user-added information. For example, Google provides access to Google's points of interest through the Places API, but it does not provide access to the Google Road Network. This map shows the result of an API query for restaurant venues in Foursquare for part of the Gainesville area. Foursquare venue data are derived from crowdsourced check-in points. A small cluster of restaurants can be recognized at the Reitz Union Student Center, as highlighted by the arrow. This map only visualizes a small part of the over 100 different venue categories found in that area. Using additional programming code, the data collection that is acquired from an API can be exported to a range of widely used data formats for further processing or data visualization, including CSV, GeoJSON, Esri shapefiles, or PostgreSQL tables. Some crowdsourcing platforms do not provide a structured data download option, but are rather designed for web visualization. In these cases, it may be possible to crawl through the HTML source of these websites and retrieve information that is relevant for further data analysis. The crawling is typically performed through customized scripts that can quickly crawl through thousands of downloaded websites. One example of such a platform is Dronestagram. This is a photo and video sharing website focused on pictures taken by lightweight drone models. This figure shows a drone photograph taken in Florence, Italy, embedded in the Dronestagram website. The website also provides metadata such as the drone and camera type used, photo tags, the number of views and likes, and a map with the photo location. This information is only shown on the website but is not provided for download. Parsing the HTML source and the embedded information allows the extraction of this information for storage in a database. These lines show a small portion of the HTML and JavaScript code of the previous website. For many types of analyses, the locations of uploaded drone images are necessary. The highlighted portion of the source code shows the approximate geographic location expressed in latitude and longitude from which the image has been taken. Using this source code information, the photo position can then be mapped in Google Earth. With a complete set of images, spatial clusters of drone images could be examined. Finally, some commercial applications only offer crowdsourced data for purchase. Meanwhile, these same applications provide data visualizations for free on the web. Strava is a platform that fits this description. It is a website and mobile app used to track one's sports activities, such as running, cycling, or skiing, using GPS-based positioning. This photo shows a smartphone mounted on a bicycle handle that runs a sports app for tracking a cyclist's activities. Heat maps, which can be explored online on the Strava website, visualize aggregated activity counts along road network segments. In this example, a heat map visualizes the frequency of cycling activities across the U.S. Areas of higher cycling usage are shown with a brighter color tone. A closer zoom into an area of interest, such as the city of Portland in this example, shows cycling frequency at the street level. Transportation planners can use this detailed information to improve the infrastructure for bicyclists and pedestrians. More detailed usage data can be purchased from the company along different product lines for refined analysis of travel behavior. Although crowdsourced data is made widely available, it comes with copyright licenses that vary between platforms or even within platforms. These licenses describe how one's individual creative product, such as an image, audio file, or field observation that is shared with others, can be used. One widely used family of licenses is the Creative Commons license framework. This comes in 6 main licenses that differ by the level of restrictions for reusing shared data. For example, an image from iNaturalist under the Creative Commons Attribution Share-alike license can be used and published in your own blog post in which you write about a specific organism. You, as an end user, are free to use this picture and even to modify it for your post, as long as you give credit to the original photographer, and as long as your work, such as the modified photo, is shared under the same conditions. This ensures that the photo and its derivatives will always be available to the public. The same concepts can be applied to data as well. Creative Commons licenses are used for images shared on Flickr, for the cartography in OpenStreetMap tiles and the OpenStreetMap documentation, and for street-level mapillary images. While the graphic content of OpenStreetMap and Mapillary use the Creative Commons Share-alike license, photos in Flickr use several of the main types of Creative Commons licenses, including the Attribution Non-Commercial Share-alike type shown on top. The Open Data Commons Open Database License, or ODBL for short, is a share-alike license agreement intended to allow users to freely share, modify, and use a database while maintaining this same freedom for others. As an example, OpenStreetMap data itself is licensed under ODBL. This means that a user is allowed to share OSM data, produce work from OSM data, and to modify and build upon the database, as long as the user references the OSM data source, offers the adapted database also under ODBL, and keeps the distributed database open without technological measures that restrict the work. Commercial applications such as Google or the navigation service platform here have other customized terms of service. For example, maps, aerial imagery, or photographs from Google or here cannot be used to trace roads in OpenStreetMap because their licenses and terms of use forbid you to do so. When sharing one's images on a web application such as Twitter or Instagram, it is recommended to read through the platform license terms. Once a user posts images on these sites, the social media site is allowed to use that photograph in any way they see fit for free. This includes letting others use your picture as well. For example, each time you post on Twitter, your right to get paid when others use your name, likeness, or voice for commercial gain, such as product or sports endorsements, is stripped away. While one can freely use certain services like Google Maps or Google Street View images without paying for them, this fact does not mean that the end user is free to do anything with the data, such as using it for research. Free as in beer in this context refers to freeware or gratis data, but with certain restrictions on their use. As opposed to this, free as in speech refers to software or data usage without any restrictions, which is also captured by the term open data. OpenStreetMap and Wikipedia are examples of enterprises which create this freely licensed content. This presentation explained the main data collection methods of crowdsourced geographic information, which includes mobile apps and web portals. It also demonstrated common data access methods for selected crowdsourcing applications such as iNaturalist and Strava. Lastly, different licensing types found in crowdsourced and commercial datasets were discussed.